Now, on to the next one, number 17. If 1 plus 1 over p and 1 plus 1 over p plus 1 are the roots of the equation ax squared plus bx plus c equals 0, prove that a plus b plus c all squared equals b squared minus 4ac. I believe this is simple. These are the roots of this equation. We should now prove that the coefficient, the quadratic coefficient the quadratic coefficient plus the linear coefficient plus the constant all squared equals b squared minus 4ac. How do we prove that? Let's wait there and let's start. And you see, this is now this is the question we are given: ax squared plus bx plus c equal to 0. Now, normally, given a standard equation, the sum if alpha and beta are the root, but you know our roots are not alpha and beta in this case, but we just say if alpha and beta are the root, then the sum is what? Minus b over a, and the product is what? C over a. Now, but we know one of our roots, alpha, they gave us that in this question, alpha is, let's take alpha to be what? 1 plus 1 over p, and beta to be 1 plus 1 over p plus 1. So that was what we said here. Now their sum, alpha plus beta is going to be what? Now this one we did a finished work here. Now find the LCM, then we get what? This will be over 1 p in p, that's 1 in p. You know, this is the same as over 1 over 1. Then 1 in p times 1 p in p, 1 times 1. So that's how we got p plus 1 all over p. And similar argument, 1 in p plus 1. You know, the LCM of 1 and p plus 1 is what? P plus 1. 1 in p plus 1 is what? P plus 1. P plus 1 times 1, p plus 1. P plus 1 in p plus 1, 1 times 1, 1. So that's how we got this one to be what? P plus 2 all over p plus 1. Now, alpha plus beta will be alpha plus beta. Alpha plus beta. So this will be this plus this. LCM. You get what I'm saying? LCM is going to be what? P times p plus 1. Now, p in p times p plus 1, we are left with what? P plus 1. P plus 1 times p plus 1, that's what? P plus 1 all square. And then p plus 1 in p plus 1, p plus 1 in p times p plus 1, that will be what? P times p plus 2. That's what we have here. And then we open the bracket to make it very easy. We expanded this. P plus 1 all square, that will be what? What we got here. You can do that to solve. Of course, that will be p squared times 2p plus 1. And then p times p plus 2, that will be what? P times p squared. P times 2p is what? 2p. Sorry, p times 2. P times p squared. P times 2, 2p. All over. We don't need to open this. I don't know. It's not really significant. Now, are we there? So we have p squared plus p squared. That's 2p squared. 2p plus 2p. That's 4p plus 1 all over p into p plus 1. So that is what we get for the sum. How about the product? That will be alpha times beta. This is alpha, this is beta. That will be this times this. Of course, when you have a fraction like this, multiply each other. You multiply the numerator, multiply the denominator. Now, somebody is saying this can divide this, yes. But we first show you that will be this times this over p plus 1. Why do we need to do it that way? It's because this one too is in p plus 1. Denominator of what? P into p plus 1. So note that. We can actually recall that along the journey. So then we got it to this point. Are we there? So that's this times this equal to this times this equal to this, then the like stuff, this one divide this, we are left with this. So hence, this one, you know, this is the sum. This was what we get for the sum. And the sum is what? Minus b. This is alpha plus beta. Alpha plus beta led to this. And the same alpha plus beta is minus b over a. Then we can conclude that this one equals minus b over a. So that was what we did here. That what we get for the sum equals minus b over a. What we get for the product equals c over a. Now from here, from equation 1, I wanted to make b subject of the relation. So b is going to be what? B will be a times the whole of this. So that was what we did. You know, a can only multiply the numerator. I believe you know that. So then bring the minus to the other side. So that's how we got this. Making a subject of formula. And then from here we make c subject of the formula. So c is going to be what? A into p plus 2 all over p. Are we together here? And we now go back to the fact that don't forget that this product is actually all of these. That's what I told you, that we can actually record it because we want it. Why do we need to do it this way? It's because looking at B, we want the denominator of B to match the denominator of C. Then what is A? A is the same as itself. A is A. Now A times 1 is the same as when saying, since we want the denominator to match, of course, you know the denominator times the denominator over itself, 2 over 2 is still 1. So that's how we write. A is the same as A times 1. Now 1 is the same as the whole of this. Somebody will say, why are we writing the whole of this? I said it once again, we want the denominator of everything to match. The denominator of everything to match. So that's why we said, okay, instead of we just writing it alone and then we create another, okay, why not just bring it so that everything will have a common denominator. Now, how do we do this kind of thing? We want to prove a statement. Let's go straight back to the question. We want to prove a statement. Number 17. This is the statement we want to prove. And moreover, this is not a direct stuff. Like you see this guy, the roots. So they are kind of this thing. So we can only prove it like somebody that is doing, what do you call this one now? Trigonometric proof in identities. That you prove the left hand side and go. So this one we check the left hand side, we check the right hand side. If we get the same thing, then they are correct. If we don't get the same thing, then definitely the statement is wrong. That's how we prove it. Impute the left hand side and do everything they want you to do. Impute the right hand side and do everything they want you to do. Just know ABC, know ABC. And that was what we did here. We already know our A is this. Our B is the whole of this. And our C is the whole of this. So we're going to do A plus B plus C first. A plus B plus C. So that will be this plus this plus this. Are you there? A plus B plus C. That will be, this is A, then plus B, then plus C. Now, don't forget, now if you look at everything, this one is having A, B is having A attached to it, C is having A attached to it, A is having A attached to it. So we can actually factorize the A, and then we are left with what? In A, we have, thank God, now, you now see the reason we said everything should have the same denominator, so that life will be easy for all of us. We don't need to be stressing ourselves, okay, let's find the LCM again and all that. We already settled that. So that will now be what? Just care about the top, because they all have the same denominator. Are you get what I'm saying? So since it's just like when you have 1 over 2 plus 1 over 2, let me say 1 over 2 plus 3 over 2 plus 4 over 2. You can just say everything over 2, 1 over 2 plus 3 over 2 plus 4 over 2. We used to tell you in fraction, just pick one of the denominator, then run the operation on the numerator. So that's just what we did here. Pick one of the denominator, then A, just care about the top of it. The top of it is what? P into P plus 1. And then B is what? Minus. There's a minus in B. All of this, minus all of this, minus into bracket 2P squared plus 4P plus 1. And that was what we wrote here. And C is what? We said we can actually write C this way. Just the top of C again. P plus 2 times P plus 1. That was what we wrote here. Do you see that? Now the next thing we did in the next line, all over the common denominator, the next line, of course, A is still outside, we factored A. So P times P, P squared, P times 1P. Now minus, you open the bracket with minus, minus times this, minus, minus times this, minus, minus times this, minus. And then expand this. P times P, P squared, P times 1, 1P, 2 times P, 2P, 1P plus 2P, that's what, 3P, 1 times 2, 2. Do you understand? Just expansion, basic expansions. So from there, we're now looking at the bracket. P squared. This is P squared minus 2P squared. That's minus 1P plus 1P squared. You know, P squared plus P squared is 2P squared. Minus 2P squared, that's off. Again, P plus 3P. P plus 3P, that's 4P, minus 4P, again off. So you are left with what? Minus 1 plus 2. Minus 1 plus 2 is 1. So what we have here, A into bracket 1 over P into P plus 1. That's what A plus B plus C rendered itself to be. Now you can open the bracket to now make it what? At the end of the day, opening the bracket, A we only multiply the top. So that's what we said, A plus B plus C is what? A over P into P plus 1, or like that. Do you understand? Now squaring these, it means I will square the whole of what we have here. You square everything here. So that will be what? A square over the denominator squared. So the left hand side is going to be A square over, since the denominator is P, into p plus 1. So that will be this one square and this one square. That's what we have at the left hand side. Now for the right hand side, we want to check the statement. B is still what B is. Don't forget, B is still what it is here. B is still this, C is still this, A is still this. Don't forget, so easily. So we check the left hand side. This was our conclusion from the left. Having simplified all things, everything we need to simplify. Now b square, it means we are going to square this our b. Don't forget, you can trace it back to check the b again. This is our b. We square everything here, and then by squaring this, minus times minus becomes plus. You know that a is going to be squared. You square the top, you square the bottom. So we square the top, we square the bottom. That's where this one leads. I believe you understand. B square is going to be squaring b. Everything here is b, then square it. Minus times minus, that's plus. A is squared. This one is squared. This one will be squared. This one will be squared. Then that's that. Now 4 times a times c. That will be 4 times. Don't forget, a is what? A is here. You've seen it. A is a into bracket p into p plus 1 over p into p plus 1. And then c is what? C is a into bracket p plus 2, p plus 1 all over p into p plus 1. So that's what we did here. 4ac, 4 times d is our a and d is our c. But this is having a and a. Don't forget, there's c, you see a around c, you see a around c, you've seen a around a. So that's why we have a here, and a here. So a times a, that's a square. Are you there? And then when you look at this one, p times p plus 1, you know everything is multiplying each other, so you can, multiplication is always beautiful. P plus 1 times p plus 1, that's what? P plus 1 all square. And then we are left with what? P times p plus 2, that's what we had here. All over this one multiplying itself, that's p square, p times p square, p plus 1 times p plus 1, p plus 1 square. Now, what do you have to do? B square minus 4ac. This is our b squared, and this is our 4ac. So that's how we wrote it. B squared, everything here, minus 4ac, everything here. That's how we wrote here. B squared, 4ac. This is why we simplify 4ac to. So that will be b squared minus 4ac will be everything here, and then minus everything here. That's what we had here. Now we are now simplifying, just to open the bracket, simplify all terms. We said 2p squared plus 4p plus 1 is going to be what? 2p all squared. All squared. We are simplifying this one. So that will be what? This one times itself. And that was what we did here. And then I made it very simple. Look at it here. We just do 2p. Now we use this bracket to multiply this bracket. That will be 2p squared times all of this. The video is already getting long, so I will run through some things. 2p squared times all of this, and then 4p times all of this, and 1 times all of this. That one led to this point. That one led to this point. That one led to this point. You can do it yourself. It was well crafted. Now, p plus 1, now the second part, p plus 1 all square into times p into p plus 2. So p plus 1 all squared is what? P square plus 2p plus 1, and then p into all of this, p times p square, p times 2, 2p. And then expanding that one again, expanding it, we got this beautiful result. Expanding that part, we got that beautiful result. But don't forget, we've not multiplied this one. Everything we have here, there's a 4 here that is multiplying it. There's a 4 and an a square here that we've not applied at all. A minus 1 and a square. Don't forget that too easily. So coming back, we now want to apply it. So b square minus 4ac. Actually, there's an a square here. There's an a square here. Why not bring out the a square? So that was what we did. So we brought out the a square, and then the 2p square plus 4p plus 1 all squared. This was where it leads. So we wrote it. Do you see that there? Do you see that? And then what we get for this is AC, not 4AC. What we get for AC, then we multiply 4 with it. 4 times AC. I get what I'm saying now. So A is common to this two. We factored it out into bracket. The whole of this, we wrote it. And then minus 4. Minus 4 times p raised power 4. Minus 4p raised power 4. Minus 4 times 4p cubed. That will be minus 16 cubed. Minus 4. You know, we factored out the a square. We factored out the a square here in this place. So that's going to be minus 4 again times minus 5. Minus 4 times 5p square. That's minus 20p square. Minus 4 times 2p. That's what? Minus 4 times 2p. Sorry. Minus 4 times 2p. That is what? Minus 8p. Do you see that? just expansion. We factored out the a square. There's an a square here, there's an a square here, so we factored it out, and then we wrote the whole of this. That's all we wrote to this point. And then minus 4. This one will be left with minus 4 to multiply everything here, and then we expanded. We got from this place to this place. But note, since everything is positive here, then if a negative number is multiplying everything, it will now be negative, 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 negative. And then we now have 4p raised power 4 minus 4p raised power 4, that's of 16p cubed minus 16p cubed, that's of 20p squared minus 20p squared, that's of 8p minus 8p. That's of. So we're left with 1 again at the top. So that will be a squared into 1 alone at the top over p into p squared into p plus 1 all squared. And this is what we get at the right hand side too, when we did b squared minus 4ac. Now, someone is saying this is b squared minus 4ac, the right hand side. Let's say the left hand side again. Now, when we did the left hand side, don't forget, what will we get? A squared over p squared into p plus 1 all squared. When we did the right hand side again, what did we get? The right hand side, we get a squared over p squared into p plus 1 all squared. So the right hand side equals the left hand side. Hence, the statement is correct and valid. What they said is actually true, and we've been able to prove that. Given that condition, given the condition they gave us, given that 1 plus 1 over p and 1 plus 1 over p plus 1 are the roots of this equation, then this statement is true, because our left hand side equals the right hand side. Our left hand side, this is the right hand side conclusion. This is the left hand side's conclusion. So since the two matches, the statement is true and valid.